Alright, we got P2 notes. There's only 2 pages to P2. You should be able to have got the vocabulary from the beginning of like page 14. Do the following points lie on the graph? That's a straight substitution, and either the two sides equal one another or they don't. So for no, you're going to sketch by plotting the points by hand. First of all, you have to solve for the y, and that we should be able to do without too many problems by moving the 2x over. So we get y is negative 2x plus 6. You're going to substitute in negative 1, 0, 1, 2, and 3, and then come up with the y values. Again, something you've been doing for quite some time and should be able to come up with those values. Plot the points. Fill in the words here from the book. Again, we have another problem this time. It is a square, so that's going to change what the graph looks like, but it doesn't change what you do. You're still going to put in negative 2, negative 1, 0, 1, 2, and 3 by hand. The graph is a parabola. It's referred to as a quadratic. You need to make sure you have the proper vocabulary when talking about your different types of polynomials. Alright, when we talk about this point plotting by hand, it can lead to misrepresentation because you may not plot very many points if you're having to do it by hand. So graphing utility is obviously much more time efficient. What we have here is that when graphing a utility, we use this point plotting to graph. The pixels are the small areas on a grid. The resolution is the number of pixels per square inch. The more pixels per square inch, the higher the resolution. We're going to use a graphing utility in the standard viewing. So what does that mean on your graphing calculator here? There we go. That's a little bit better. Under Zoom, you have these options of different ways that you could look at your graph. Number 6 is standard. So when it says your standard viewing, that's actually Zoom number 6. And that's the one that you'll default to give you a 10 by 10 screen XY axis. Alright, so let's look at this equation that it wants us to graph. First thing you have to do is you have to solve for y. So we're going to move over the x cubed, and then we're going to divide by it. So we get negative 1/2 x cubed. Divide by 2 is 2x. So that's the equation that we're going, cubed, sorry, not squared, cubed, that we're going to plug in under y equals negative 1/2 x cubed. So x, and then to get anything other than a square, we use this little caret key, and 3, so negative 1/2 x cubed plus 2x, and we're going to graph. Now again, this is on a standard window. That's the 10 by 10. So what do we see? And just sketch it in there. It doesn't have to be exact, but something close. There's our standard window. Now it says you're going to change the window, and we're going to change it. This is our x minimum maximum and our y minimum maximum. It's missing a number here called the scale. So we're going to go to window. We're going to change the window to x minimum is 0. We're going to do x max at 0.5. There should be another number here that says the scale, and we're going to do it by 0.1, so 0.1. And then we're going to do the y minimum, the y maximum, and again the same scale. Now when we graph it, notice the difference in what our picture looks like. Looks like just a straight line. Alright, we're going to change the window again. we're going to do our scale, so let's put another number back here, by ones. So window, 0 minimum, 6 maximum, by 1. -3 is the y minimum, +3 is the y maximum, the scale is +1. And again, look at the scale, and it looks something like that. Clearly, these three pictures don't look anything alike. They don't give the true representation. So knowing your windows and knowing your scales is a very important factor when it comes to knowing what a graph looks like and the information that you need to give regarding it. So using a graphing utility and standard viewing, so again, standard viewing, we're going to go back to Zoom 6. And we're going to graph x squared plus y squared is 9. Well, what should this figure be? From the last section, P1, if you have an x squared plus a y squared, it's a circle. So it should be a circle. But in order to graph it, you have to solve for y first. You will be solving these for y, so you need to make sure you know how to do that. First of all, you're going to subtract the x squared over. So we're going to get y squared equals 9 minus x squared. Then we're going to get y equals, because we don't want square, we just want y. And when we square root a square to get the single, we get two answers, plus minus, and then 9 minus x squared. You cannot factor that. It does not matter. You cannot do anything with that. Leave it alone. So now we're going to punch it into our calculator. We're going to go back to standard, so Zoom 6. Y equals, and we have two equations. We have a positive equation, so the square root of 9 minus x squared. And then we have the negative of square root 9 minus x squared. Whoops. Let's go back there. The negative of the square root 9 minus x squared. When I graph this, it doesn't really look like a circle. It looks more like an ellipse. And the reason for that is because of the stretching of the 10 by 10. This is a rectangular screen, not a square screen. So if we want to see its true shape, we need to go to Zoom Square number 5. Now we see its true shape. So to make the graph look like a circle, we're going to use Zoom number 5, the square grid. That way we see that it is truly a circle and it is not an ellipse. Alright, for this 3 common approaches to solving the problems we've already talked about, and it's going to be the most important thing that we do in all of our pieces, and that's our gnaw process. We need to be able to graph. We need to be able to do numeric, which is our t-tables. We need to be able to do it algebraic, and we need to be able to do it in words. This is our gnaw process. This is something that we are going to have to be able to do in all formats, in all polynomials, in all word problems, in everything. We need to be able to look at every problem in these formats. Let's see, we got do it algebraically, numerically, and graphically. You receive a monthly salary of $2,400 plus a commission of 10% sales. So algebraically, we're going to do the verbal, so that's our words. We're going to say the total earnings is the salary plus the commission. That's what it is in words. But the algebraic is going to take those words and put it into mathematical symbols. So total earnings, maybe we call T. We're going to take salary, so maybe S, plus 10%, because that's what we know, of our commissions. So maybe we use C. So there's our algebraic model or translation of numbers, words into symbols. Now we're going to actually do it. If sales are $1,500 in August, what are your total earnings for the month? Well, we know the total earnings are the salary plus 10% of the commission of sales. So commission is $1,500. So that when we work it out with our calculator, we should have got $2,550. So just a little, again, just a little trial here. What are the total sales if, I'm sorry, it says if you received, so that's what you, total earnings were, 2,665. What are your sales? So that's your 10% of your commission sales when you know your salary. So we're going to subtract off the 2,665 minus the 2,400 to get 265 is 0.1 of your C, and then divide by the 0.1. So your commission on the total sales, what were your sales? They were $2,650. Alright, so that will take care of P2.